Hello everyone and welcome back to our Chapter 1/Histology discussion. Okay, where we last left off, we talked about epithelial tissues and we talked about how epithelial tissues are just one of 4 different types of tissues that make up your entire body. The next group of tissues that we're going to talk about are connective tissues. And as the name suggests, the job of connective tissues is to connect the epithelium with the rest of the body. So as we did in our very first lecture, what I highlight is probably really super important. So the things that are on this list are jobs or types of connective tissue. Of all the different tissue types that we're going to discuss, connective tissue is probably the most diverse. There's so many different types of tissue that fall into this connective tissue category. So examples of connective tissue would be bone, whose job is to provide support, fat or adipose tissue, which stores energy, and blood is also considered connective tissue, and it transports materials. Now, although bone, fat, and blood are vastly different from one another, they do share a lot of features. And the feature that they share is that commonality that they have no contact with the external environment in a healthy, intact body. So some other characteristics that bones, fat, blood, areolar tissue, tendons, ligaments, all of these very, very different types of connective tissue share is kind of how they're configured. Now the types of cells that you find and the types of fibers that you find may differ from tissue type to tissue type in this connective tissue umbrella. However, they all have these same components. So components that you'll find in all types of connective tissue would be that they consist of specialized cells. So bone has specialized cells that we call osteocytes. Fat has specialized cells that we call adipocytes. Then we have tendons have, well actually they don't have any specialized cells, they're more like they have fibers to them. But the point is that there are specialized cells that make up these different types of tissues. Another hallmark that all connective tissues share is that they have these extracellular protein fibers. Keep in mind, in much the same way that the specialized cells are different from tissue type to tissue type, they're also in red blood cells and white blood cells are in the blood tissue type, connective tissue type. There are special types of protein fibers and there are different combinations of them. So the density of the amount of protein fibers that are in one tissue may differ from the density of protein fibers in another type of connective tissue. Another characteristic is that they have this fluid extracellular matrix. So proteins are the solid extracellular matrix that wouldn't be considered cells. We have the fluid extracellular matrix, which we call ground substance. Now for something like blood or lymph, it's going to have a much greater concentration of ground substances or fluid extracellular components, whereas bone is going to have a lot fewer fluid or ground substances and more protein fibers. The collection of the protein fibers plus the ground substance is what makes up the matrix. So when we refer to the matrix of the connective tissue, we're talking about its specific unique combination of protein fibers and ground substances. And ground substances, remember, those are going to be the fluid aspect of it. So classifying connective tissues, we have for all of these diverse types of connective tissue, we have 3 pretty broad classifications for them. So we have connective tissue proper, whose job, and I'm going to write that down right here, J-O-B, job is to connect and protect. We have fluid connective tissues, whose job is to transport things. And we have supportive connective tissues, which infer structural strength. That is their job, is to infer structural strength. So first let's talk about the connective tissue proper. Now underneath that umbrella, so remember, we're talking connective tissue. In connective tissue, we have a very diverse category. So because it's so large and it's so diverse, we want to have a way to try to organize this large, diverse category, right? So first we're going to work, so the 3 different groups we had were connective tissue proper, fluid connective tissue, and structural connective tissue. The first one that we're going to work with is going to be the connective tissue proper. Connective tissue proper can be further broken down into 2 categories, loose connective tissue, and dense connective tissue. Now, I know you're probably thinking, whew, my mind is blown already, and we're like 5 minutes into this thing. So that's why for my students on Blackboard, I have composed and I have put together a little flow chart for the connective tissue proper. So I'm going to go ahead and share my computer screen with you all so that you all can see, everyone can see the flow chart and kind of have an idea of how to build your own flow chart. So just bear with me one moment while I get my flow chart out and display it to you all. For my A&P students, it would be found in the lab lecture content folder, and then go into lecture notes, and underneath the very first chapter, it'll say connective tissue flow chart, and that's where you will find it. So I'm going to go ahead and I'm going to share my computer screen so that we can all look at this together. So here is that flow chart that I've made. So notice that we have our connective tissue up top, and then we have our 3 different types of connective tissue, those large categories: connective tissue proper, fluid connective tissue, and supportive/structural connective tissue. And then we're going to start with connective tissue proper, and the connective tissue proper can be further broken down into dense connective tissue and loose connective tissue. This connective tissue is going to be, just as the name suggests, it's going to be very dense. So when we think of things like tendons and ligaments, whether they be elastic ligaments, intervertebral discs, well, actually they're cartilage, but any of those ligaments and tendons, we're thinking more of this dense connective tissue. So because it's a dense connective tissue, it stands to follow that there are more ground substances, there are more there are fewer ground substances and more protein fibers that are found in this tissue. Now, when we go down and look at the different types of dense connective tissue, notice that it goes from dense regular to elastic connective tissue. Dense regular connective tissue is going to be the most rigid and the most straightforward. Irregular connective tissue kind of falls in between, and then the elastic connective tissue is going to be the loosest of those. So let's go ahead and go back to our notes. I can figure out how to get back there. Okay, this is interesting. Gotta figure out how to get back. Sorry, I thought I knew how to do this very quickly, and apparently I do not. Let's try this. Wow. Okay, that's how we get back. Sorry about that. All right, so remember, for under connective tissue proper, we have those 2 different categories, loose and dense. Dense we talked about, more fibers, fewer ground substances. So more solid, fewer ground substances that we have there. Examples would be tendons. Now, loose connective tissue is going to be the opposite. We're going to have more of these ground substances and fewer fibers are associated. A great example of loose connective tissue is adipose tissue, or fat. Now, For all of those different types of connective tissue that we've talked about, these 9 different cell types are going to be properties of them. So you won't find all 9 of these different cell types in all of the different types of connective tissue that we're going to talk about. But when we start to talk about things like fibers and ground substances and specialized cells, this is specifically what we're talking about, some of which we're talking about. So we can have things like fibroblasts, which would be a type of protein fibers that give rise to fibers. They actually give rise to fibrocytes. We have fiber, and those fibrocytes can give rise to things like proteins, and proteins will be considered some of the fibers that we're talking about. We have macrophages, which will provide an immune response. Macrophages, lymphocytes, and microphages, things like neutrophils and eosinophils, they would be examples of cells that would elicit immune response. Adipocytes give rise to fat cells. Mesenchymal cells are stem cells that can become any one of these 9 tissue types on here. So these are really cool. These are your adult stem cells. Melanocytes are going to give rise to cells that produce melanin. Mast cells are also part of, they elicit an immune response. So notice how of these 9 cell types, 1, 2, 3, 4 of them actually help to elicit an immune response. And remember, not all of these different types of cells are found in all connective tissues all the time. But these are just a list of some types of cells that you can find. So more detailed discussion on these different cell types. I won't go over all of them again because I feel like we've talked about them. Macrophages are going to provide an immune response, and they can eat things. They eat pathogens and damaged cells. They can either stay in one place, and we will consider those fixed macrophages, or they can move around, that we call them free. Adipocytes are fat cells. Each one of those cells is going to store just one droplet of fat. And remember, mesenchymal cells are the adult stem cells, and they're going to respond to injury or infection, where they can become any one of those other 9 tissue types. Interesting fact, if you have liposuction done, if you don't change your diet and you don't change your lifestyle as far as eating well and working out, the place that you had the fat sucked out from, although those adipocytes won't divide again, because the cool thing about fat cells is that they don't divide. They don't divide again. They don't multiply. However, if you don't change your lifestyle and you don't change your diet, what can happen is that those mesenchymal stem cells can become new adipocytes, and you'll just get more liposuction again. Or you'll change your lifestyle, one of the two. Melanocytes make melanin. We'll talk more about that in our integumentary chapter. And then mast cells, like macrophages, elicit an immune response. The way that they elicit an immune response is that they release specific chemicals that help to bring more of the right types of cells to the area to deal with an infection, or to prevent clotting from happening, or to dilate blood vessels. We'll talk about mast cells a lot in A&P too. Lymphocytes, also an immune cells. They're from the lymphatic system. Lymphocytes can develop into T cells and B cells, and B cells are also called plasma cells. They make antibodies. Macrophages are things like neutrophils and eosinophils. They're phagocytotic blood cells. They're smaller than macrophages are. That's why they're called microphages, but they also elicit an immune response. Now, on to those fibers that we can have. So the first type of fiber that we're going to talk about, and remember, what makes up the matrix of connective tissue? Protein fibers and ground substances. Of the two, which are the solid portions of the matrix, those would be those protein fibers. Here is an example of said protein fibers, collagen fibers. The most common of the fibers in connective tissue are collagen fibers. And these collagen fibers help to infer a lot of strength. Collagen fibers are typically going to be found long and straight, and they don't branch. Sometimes they're wavy, and when I say they're wavy, sometimes they look a little bit like this, but they're going to always lie parallel to one another. So there might be a little bit of a wave configuration going on to them, but they're not going to branch off in various different directions, which we'll see in different types of muscle cells. They're very strong, they're very flexible, and they can resist force in one direction. Examples of your parts of your body that are made out of almost strictly collagen fibers are your tendons and your ligaments. But keep in mind that there are parts of your other parts of your connective tissue proper that also have collagen fibers. Like underneath your skin, underneath that epithelial tissue, you have a relar tissue which also has collagen fibers. Now, as you get a little bit older, and depending on your genetics, those collagen fibers aren't able to withstand all of the stretching that may happen to them, so that may cause some sagging and indentation of the skin, which we would characterize as wrinkles. So a little bit of a clinical note here. So Marfan syndrome is a genetic condition that is caused by relatively weak fibrinogen, and that's a protein that gives the strength and elasticity to connective tissue as it refers to collagen. Now, Marfan syndrome, at first we thought it was a disease that would affect many different organ systems. We see it affecting the bones, we see it affecting the muscles, we see it affecting ligaments and tendons. We would see it affecting the circulatory system, and that a lot of patients that have Marfan syndrome, a lot of people that have Marfan syndrome will also have instances or points where they would have an aortic aneurysm, which means their aorta kind of balloons out because it's not able to withstand the pressure of the blood being pumped out of it from that left ventricle. So it kind of just balloons out, and sometimes it can burst while inside the person, and they would hemorrhage, and it can be fatal. So we used to think that Marfan syndrome just affected a lot of different organ systems. And the question we asked was, why is it so widespread? What we were able to eventually figure out is that Marfan syndrome is as a result of defective collagen. And in all of those places that we discussed, ligaments, tendons, muscles, the walls of your aorta, all of those different areas have collagen. So if the collagen is going to be disrupted or defective and just wherever, then everywhere you find collagen, you find the same problems. So now on to the other type of fibers. We talked about one type of fiber that's very common, and those are collagen fibers. In fact, it's so widespread, almost in every portion of the body there's going to be some degree or another of collagen fibers. Other type of fiber that we will find are elastic fibers. Elastic fibers are branched, and they're much more wavy than collagen fibers are. And the reason I kind of showed a little bit of that wave characteristic, because depending on the type of slide, the histological preparation, they could look wavier than others, but they're fairly straight. Elastic fibers are loosey-goosey wavy, so they're going to be doing something like this. So they have much more squiggles to them. They're not just all in the same line as we expect for collagen fibers, where they're like little toy soldiers. They're all straight and they all go in the same direction. Elastic fibers are your hippies, so they're kind of just all over the place. And it's fine for elastic fibers to be branched, and sometimes they'll branch off like this. It's fine for them to be branched and to be wavy because they have a property that collagen fibers don't have. They can withstand more stretching and then recoil back to their original shape. Example of where you would find a structure that has a lot of these elastic fibers would be in the elastic ligaments of your vertebrae, or that keeps your vertebral column and gives it some flexibility to it. I know many of you all watched the Olympics here in 2016. Like the rest of us, and you're just absolutely amazed by some of the feats that the gymnasts and these other world-class athletes can perform. And what allows gymnasts like Simone Biles to do the different backflips and front flips and have the flexibility that she does is that she's got these elastic ligaments in her vertebrae. You've got them too, but she has trained her body for a very long time to really manipulate these her body features and to really get the most out of her elastic ligaments. Most of us do is bend down and touch her toes. So ground substances, remember this is the fluid portion of it. It's going to be clear, it's colorless, and it's kind of viscous. And by being sort of viscous, when I say viscous, think of something like molasses. It helps to retard or slow the movement of pathogens so that your immune cells, those macrophages, microphages, and whatnot, are able to kill the pathogen before it does too much damage. So the ground substance is kind of a viscous sort of thing. Now keep in mind, not all connective tissues have the same amount or same ratio of proteins, fibers, and ground substances. It's going to differ and change depending on what type of tissue we're talking about. So here is a picture of areolar tissue, and what we are noticing in this areolar tissue are that we have these collagen fiber bundles. Notice how they're all going in the same direction. And when I say they're all going in the same direction, all the collagen fibers that are in this bundle are going the same way, and all the collagen fibers in this bundle are also going the same way. We also have some elastic fibers that we have here. Elastic fibers tend to be more thin, and they tend to be more renegade. They don't always hang out together, not always congregate together the way that collagen fibers are. And then we even see some different cell types here where we have macrophages and we have fibroblasts. So loose connective tissue, keep in mind we're still underneath just the umbrella of connective tissue proper. And we talked about dense connective tissue, and in that dense connective tissue category, we talked about how we had dense connective tissue, we have elastic connective tissue, and we haven't really gotten to the irregular portion of it. But for the loose connective tissue, that's on the other end of the connective tissue proper, on the other end of that umbrella. And there are three different types of loose connective tissue. We have areolar tissue, which we just looked at on the previous slide. We find that underneath your skin. We have adipose tissue, which we've talked about, and remember adipose is a fancy word for what? Fat. And then we have reticular tissue. Reticular tissue is kind of special. It's still considered loose connective tissue, but reticular tissue is only found in your liver or primarily found in your liver. That's the best example we're going to use for it. So areolar tissue, some hallmarks of it is that it's not very specialized and it has more of an open framework. So if we go back to this slide here, oh, I lost it. There we go. We go back to this slide here. This is areolar tissue. You can kind of see it looks like an abstract painting. So it's got a very open framework. There's definitely some open spaces here, and there are different types of fibers that we find. Lots of collagen fibers, but if we look at a different portion of this connective tissue proper, this areolar tissue, then you would see that we have more elastic fibers as well. So areolar tissue, open framework, not really super specialized. So it doesn't really have all the specialized cells that we might see in like adipose tissue or reticular tissue, loose connective tissue. Viscous ground substance, and it has some elastic fibers and, you know, primarily underneath the skin, and it holds blood vessels and capillary beds. Adipose tissue is going to be much more specialized. In fact, it has its own specialized cells. And those specialized cells are called adipocytes, or called fat cells. And it even has two different types of adipose tissue that we can have, white fat and brown fat. White fat is considered adult fat. It's the most common. The job of this white fat is to store the adipocytes or for energy storage. It acts as a shock absorber, and it can also retard or slow heat loss. So it acts as an insulating factor. Now, brown fat, on the other hand, is called brown because it's more vascular, which means it has more blood vessels that come to it, so there's more energy that comes to this brown fat. The adipocytes in brown fat are also going to have lots of mitochondria, and that makes sense because it's vascularized. Anytime you're having a nice steady blood supply come to something, chances are that the mitochondria are going to be working to provide energy, because that's the job of the mitochondria. They're the powerhouse of the cell, and they provide energy, and they provide more energy in part because they get oxygen from the red blood cells. Brown fat we find mostly in children and in infants when it's stimulated. We do have some in adults, but not nearly as much as you do when you're an infant. When it's stimulated by the nervous system, so if the body were to get too cold or not have enough energy, then we can outsource this, use extrinsic regulation, and accelerate the release of energy from that area, and that will increase the temperature, and it would also help the rest of the body with its energetic needs, which is one of the reasons that babies don't really shiver. Small infants don't really shiver because they have more of this brown fat. Adipocytes, as we said before, they don't divide. So your doctor that gave you lipo and says, you know what, where I sucked this fat out from, those cells are gone. They'll never divide. He's telling the truth. Adipocytes in adults don't divide. They can expand to store fat, and then they can shrink as the fat is released. So when you lose weight, the question is, where did it go? Well, you literally burned it all off. That you took that energy, which is what's stored in adipocytes, and you used it exercising or biking or running or whatever it is you do as your exercise activity. And so those adipocytes or fat cells are going to shrink. However, as I said before, if you get liposuction and you don't change your diet and you don't change your lifestyle as far as your exercise routine, then those mesenchymal cells can divide and say, looks like somebody needs some more fat cells. And they can actually make more fat cells when that storage is needed. And what would be a situation that will allow for more storage to be needed? Well, you're eating more calories. You're consuming more than you're actually burning off. So the third type of loose connective tissue is reticular connective tissue. Reticular organs such as your liver and your spleen and your bone marrow, they consist of reticular connective tissue. Three-dimensional framework primarily provides support. We don't really talk about reticular connective tissue. In fact, we're not even going to look at any of it in lab. Now, on to the dense connective tissues on here. Remember, we already talked about the elastic fibers, and we talked about those protein fibers of collagen that are found in there. But those three different types of dense connective tissue were dense regular, dense irregular, and elastic. If you look at these different tissues on a political spectrum, because this is an election year, if you look at it on a political spectrum, the dense regular connective tissues are going to be your conservatives. Because they're and if you think about what a conservative is, like my dad is very strict, very straightforward. He makes his bed the same way every day. He drinks his coffee the same way every single day. He's very conservative. He likes to conserve his ways and the things that he does things. Whereas I kind of fall on the opposite end of that political spectrum. I'm more of the elastic tissue. So the elastic tissues are kind of like your liberals, as my dad would call them, tree-hugging, granola-eating, long-haired hippies. So they're kind of on that end of the spectrum. And so these are going to be tissues that are consisting of more of these elastic tissues or elastic fibers where they're kind of just all over the place. They're wavy, they're not clearly defined. There's just a lot of stuff that's going on with them. Now, dense irregular connective tissues are going to be where most people fit into the political spectrum, and that's just right there in the middle. So they're not as strict and conformist as the dense regular connective tissues, and they're not like way out there as the elastic connective tissues. So as we said, for those that are on the conservative end of the political spectrum, they're tightly packed parallel lines. Those are our little toy soldiers. Examples of dense regular connective tissue are tendons. Tendons will always connect, or a hallmark, I should say, of tendons is that tendons attach muscles to bone. We'll talk more about this at length throughout the semester. And ligaments connect bone to bone and help stabilize. The thing they both have in common is that they are made of dense, regular connective tissue. Lots of collagen fibers all going in the same direction. Dense irregular connective tissues, these were the ones that were found kind of in the middle. That they're going to be networks of collagen fibers, but they have more of an open framework to them. They're not so tightly packed, and they're not so buttoned up, I would say. They're not so conformed, they're not so strict, but they're not as loosey-goosey as elastic connective tissues. So where we find dense irregular connective tissue is layered in the skin. We also find it in the around cartilage cells, what we call pericardium, and then we find it around the bone called the periosteum. And sometimes we even have it form capsules around different organs. So this dense irregular tissue has some flexibility to it, whereas the dense regular has very little flexibility but lots of strength. The dense irregular is kind of the perfect combination of strength and flexibility. Now for our last type of connective tissue proper for dense connective tissue are the elastic tissue. Loosey-goosey, lots of elastic fibers, lots of flexibility that's going to be inferred from this. Great example are going to be the elastic ligaments of the spinal vertebrae. Now on to fluid connective tissues. Fluid connective tissues, just as the name suggests, are going to be fluid. Greatest example of those, or really the only example of those in your body, are blood and lymph. So blood and lymph are your fluid connective tissues. They're very, very different from the connective tissues that we just talked about. Very different from tendons, very different from ligaments, very different from fat, very different from reticular and areolar connective tissue, because it consists of more ground substances than protein fibers. So far, the connective tissues that we've talked about have been very heavy on the protein fibers and just a little bit of ground substance. Now we've completely flipped that model on its head, and we've got lots of ground substances, lots of fluid components to it, and very few of these protein fibers. Fluid connective tissues are going to have specialized cells, which being is another hallmark of connective tissue, that it has some specialized cells that are in there. So that's not really a big surprise for us. Those specialized cells are what we call formed elements. They consist of erythrocytes, and erythrocytes is a fancy way to say a red blood cell, and that is a term that you should remember because we're going to talk about erythrocytes for the rest of the year, an AMP1 and an AMP2. And we have leukocytes, which are white blood cells, and we have platelets. Those are the formed elements of the blood. These two would be your specialized cells. So here is a pretty picture of red blood cells, white blood cells, and platelets that we have. We'll talk in AMP2 a lot about red blood cells and what their job is in white blood cells, etc. In lab, we're going to actually get a chance to look at red blood cells and white blood cells under the microscope. Monocytes are going to be the biggest ones, and then they have this nice sort of B-shaped or U-shaped nucleus. Lymphocytes are another prominent feature of white blood cells. Their nucleus is going to take up almost the entirety of the cell. Eosinophils, neutrophils, and basophils are all granulocytes. And we'll talk in lab in length about how to differentiate one class of cell from the other. So fluid connective tissue, remember that its job was to transport things, and the cardiovascular system, the type of fluid connective tissue that it transports is called blood. When you think of the cardiovascular system, you have arteries that carry blood away from the heart, A for arteries, A for away from the heart, and then we have veins, and that's usually the case. There's like a one-time chance that's different. Then we have veins that carry blood to the heart, and then the capillaries are the exchange vessels that allow for this kind of like the bridge between the arteries and the veins. The type of fluid connective tissue in the lymphatic system is called lymph. Lymph is really nothing more than the plasma component of the blood that's now made its way into the lymphatic system. And it's going to be carried not through arteries or capillaries or veins, but through what we call lymphatic vessels. Now, we have talked about, just as a recap, let's see if I can. Probably not. Nope, not going to do that. So if you'll refer back to our tree, we had connective tissue, and underneath that connective tissue, for our flow chart, we had connective tissue proper, fluid connective tissue, and supportive connective tissue. Under connective tissue proper, we had two different types of connective tissue, dense and loose. Under dense, we had dense regular, dense irregular, and elastic. Under loose, we had adipose, articular, and we had areolar connective tissue. And then we went to the next main category, which was fluid connective tissue. Underneath that, we had blood and we had lymph. And then from there, we went to the structural connective tissue. So now we're doing the very last one. So this is the last one of our connective tissues underneath that connective tissue category. Supportive connective tissue, support, as the name suggests. There are two different classes of supportive connective tissue, cartilage and bone. The specialized cells that make up cartilage are called chondrocytes. And chondrocytes are going to always have the cell, and it's going to lie in a chamber that's surrounded by the lacunae. This ground substance that's in cartilage is much more of a gelatinous type of ground substance, and that helps to give that cartilage some give to it. And it allows for it to have this role of acting as a shock absorber and also providing some protection. Bone is going to be like cartilage in that there are specialized cells that are in a lacuna, but we call those specialized cells osteocytes. The bone is going to be calcified and is made much more rigid by calcium, salts, and minerals. We will talk at length about how bone is made, how it's recycled, the types of cells that are found in bone, and all of that fancy stuff in a couple of subsequent chapters. So for now, we're just going to talk about how bone is a type of connective tissue, and it fits in the category of a supportive connective tissue. Now for cartilage, on the other hand, this is the last time we're going to talk about it. So we're going to talk about this in a bit more detail. So cartilage is avascular. There are no blood vessels that come to cartilage. In fact, the chondrocytes will actually produce an anti-angiogenesis factor to keep blood vessels from growing there. Anti means against. Angiogenesis is the formation of blood vessels. So the chondrocytes are actually going to produce a chemical that keeps blood vessels from being made there. This you're probably very intimately acquainted with the fact that when you pierce your ear or you pierce your nose or any other part of that pure cartilage, there's very little bleeding that happens. And the bleeding that takes place is not as a result of the cartilage bleeding, but it's more as a result of different structures around that, surface structures that will bleed. So the perichondrium is that layer outside of the chondrocytes. It's got two parts to it. It's got an outer fibrous layer that's going to be really tough for strength, and then the inner layer of it is just meant to be a suitable way of growth. So for cartilage, it has three different types of categories. I know you guys are probably like, I'm so tired of these subcategories. So cartilage there's three different types. We have hyaline, elastic, and fibrous cartilage. Hyaline cartilage is going to be very stiff, and it has a lot of support, but it's flexible. So even though it's stiff, it has what we consider flexible support to it. Hyaline cartilage you find between the tips of bones, and it helps to reduce the friction between those bones, and we find it in synovial joints, places that are highly movable. Elastic cartilage is supportive, but it bends much more easily. So the outer ear consists of elastic cartilage as well as your epiglottis, that little flap that goes over and it's found in your throat or your cervical region, your throat. Fibrous cartilage or fibrocartilage is going to be the least mobile of the three. It also, like hyaline cartilage, prevents bone-to-bone contact, but it's going to be much thicker. So we find fibrocartilage in places like your pubic bones, your intervertebral disc, and also the meniscus or the pad of your knee. So that are all of our connective tissues. So we've all finished with connective tissues. The last few little slides here are going to discuss membranes and kind of how it all fits together somewhat. So membranes are considered physical barriers, and they can line or cover portions of the body. Membranes are going to consist of two main parts, an epithelium, which is the outermost portion of it, and then its underlying connective tissue. Four types of membranes that we're going to discuss: mucous, serous, cutaneous, and synovial. Mucous membranes are always going to line passageways that have an external connection. So think about all the places in your body that lead to the outside of your body, whether it is your mouth or your nose or any other place that you can think of. If it goes outside your body, it's going to be covered with a mucous membrane. Notice that a lot of these places you've already thought of yourself. So for mucous membranes, the surface doesn't need to stay moist, so it reduces friction, and it also needs to be able to facilitate some sort of absorption or excretion to take place. Serous membranes are going to line cavities that are not outside the body. So these serous membranes are going to have a thin but very strong component to them. They're going to also release a fluid, and that fluid is called transudate, and it also helps to reduce friction. Serous membranes have two components to them, a parietal portion and a visceral portion. The parietal portion is going to actually cover the cavity itself, and then the visceral portion is going to cover the organ. And we'll talk more about these serous membranes when we get to various different organ groups, and we'll specifically talk about like the pericardium, the sac that surrounds the heart, or the pleural membrane, the membrane over the lungs. There are three different types of serous membranes: pleural, which covers the lungs; peritoneum, which covers the abdominal organs, and the pericardium, which covers the heart. And for all of these serous membranes, the part that's closest to the organ is called the visceral portion, and then the portion that's outside of it is called the parietal portion. And now on to cutaneous membranes. Skin, best example of that. Thick, waterproof, dry. Moving on. Synovial membranes are going to be the membranes that are only found in highly movable articulating joints. And we call those synovial or synovial membranes. They produce a fluid just like what we saw for the mucous membranes produce mucus as their fluid to reduce friction. Serous membranes produce transudate to reduce friction. They also produce a fluid to reduce friction, and that's called synovial fluid. We find this at the ends of the bones that are found in articulating joint cavities like your knee and your shoulder joints. Unlike the other three membranes we talked about, whether it's serous or mucus or cutaneous, it doesn't really have a true epithelium. There are some epithelial cells there, but it doesn't have a full epithelium in the traditional sense. So another clinical note, our final one for this first series of notes, is called pleurisy, or inflammation of the pleural cavities, which is nothing more than serous fluid buildup. As a result, what happens here is that the area has been, there's an infection or an injury. So as a result of that infection or the injury, there may not have been enough of the transudate that was made. So the surfaces are going to rub against the organs, and that's going to cause this friction to take place. The body's way of trying to deal with all of that friction that's taking place is to try to overcompensate and with more transudate. So when it makes all of this extra transudate, it's going to lead to a gradual buildup in fluid. So what happens is that if you have this buildup in fluid around the heart or in the pericardium, then the heart can't beat effectively because there's all this fluid that's around it. Peritonitis can result from an injury or a surgery as a complication of surgery when we have to open up the abdomen, which is probably what's happened to this guy. He has peritonitis because it's not around his heart, it's in his abdomen here. So when they went to have the surgery, he had some serous fluid buildup, which can be drained, and I'm sure they've got some, they're draining that fluid. Can be life-threatening, usually it's not, because most of the time you're under the care of a physician when you get to this point. So the internal framework of the body, as you probably can already guess, kind of wrapping up this chapter with a nice bow, is that you've got a lot of connective tissues there. You've got lots of different types of connective tissues there. They help to maintain the position of those internal organs. They help to provide strength and stability. And those connective tissues, in turn, are going to give rise to the fascia, which is your internal framework of the connective tissues and the different layers and wrappings around the different organs that are required for support. Of those fascia, there are three types that I want you to remember. We have superficial fascia, which is closer to the outside of the body, still internal, but closer to the surface of the body. The deep fascia, which is going to be underlying the superficial fascia. And then we have the subserosus fascia, which is going to be the fascia that's on the inside of even the deep fascia, or closest to the organs themselves. All right, so we finished up our first section of notes here. We will then be moving on to other organ systems. I hope you all are having a fantastic day and have enjoyed this lecture. Ta-ta for now.